In this video we're going to look at the inverting amplifier. So we've got the circuit drawn down just here, and you can see that we have the op amp sitting, and in the inverting side of the op amp we've connected up a resistor, and there's a feedback loop here to the output through resistor RF. Now we use the rules that we've seen in the previous videos, so we know that the way the op amp works is that it tries to ensure that the V minus, which is the inverting input, is equal to the voltage on the non-inverting input. In this instance here we've set the voltage on the non-inverting input to 0, so the voltage at this point here should equal 0. Now whenever we analyse that just using the Kirchhoff's current laws, we can see that if we have the current flowing in this direction here is going to be V in minus the V minus divided by the resistance R, so that's just going to give us the current here, okay, flowing to this point. And if we look at V out minus V minus upon RF, that's going to give us the current that's flowing in this direction here. Now we know that there's no current flows into the input here, so it means whenever we add these currents, this current here plus that current here has to equal that current there, but that current there equals 0, so this whole thing here must equal 0. And we've seen that our V minus is going to equal our V plus, which is equal to 0, so we can replace this V minus here and that V minus there with a 0, so you're just going to end up with your V in minus 0 upon R, and if you take this here across to the other side you'll have it equaling minus V out upon RF, and then if you take the R up, okay, multiply top and bottom by R, the top line by R here, the top line by R there, you'll have our V out is going to equal minus RF upon R times the V in. So it means that the output voltage you're going to get is going to be given by a ratio of the resistors RF to R, and it's also going to be inverted, so the negative sign is going to ensure it's going to be inverted. Now I've actually built that in Multisim, and that's a circuit in Multisim, and we're going to show you me building that just in a couple of minutes, and you can see it getting built up so you can get used to using Multisim. So we've got our function generator here, which is our input, and also an oscilloscope here, which we use in order to have a look at the input and also to look at the output, and you can see our resistors here R1 and R2, and the ratio is 2 to 1, so the circuit we built here should have an amplification of 2, and it's going to invert the signal as well. And that's what we see below. I've actually put in the red one here is the input and the blue one is the output. So the red is a 1 volt peak, so it's a 2 volt peak to peak, and the output is a 2 volt peak, which is a 4 volt peak to peak signal, and you can see it's been inverted as well. Okay, so that's all there is to this video, and you have a look at the next section and I'll show you me actually building this. Okay, so for the first couple of examples I'll actually show you me building it up in Multisim so you can get used to seeing the tool and how it works, but after that we'll just actually pre-build it to save a bit of time. So we're going to build up an inverting amplifier, so you can actually press Ctrl W and it'll bring you up the component selection screen there, and from there you can go in and you've got your options here to choose all your different types of sources. Okay, so you can click on the one down here that says analog, and it's going to come up with your options for your op amps, and there's a 741 there, so you just click on that, click OK and place it. Now I'm actually going to invert that op amp because I want the negative to be up here and the positive to be in the bottom, so I want to flip it vertically. So you can do that just by right clicking, and you can say flip vertically, and then you've got it sitting like that. Now let's go and get all of the instances we need. Again, you can press Ctrl W, and if you come up here and put in sources, and you can write in the sources you need. So put in VCC, and we need VDD, we need a ground, we need a couple of resistors. So we can go in here to basic, and then you can see resistors. So we'll stick a 1k ohm resistor in, right, and we're also going to need a 2 kilo ohm resistor. Okay, now it's off the edge of the screen here, so I'll adjust it so you can see, but we're going to grab a function generator. So that's the second one down there, it says function generator. And you can place that. And we're also interested in looking at the output and input, so we need an oscilloscope, so that's the fourth one down there, and we can place that oscilloscope. So I think that's us pretty much got everything that we need. So we'll go and we'll place them in the right positions. Okay, so we'll take the function generator, so that's going to be our input over there, and we'll take the oscilloscope, which is going to we're going to use to look at our input and our output over there, and we're going to have our VCC. Now our VCC is actually going to be onto pin 7 down here, so we need to turn it around. So you go Control R, rotates it. Okay, so that allows us to place that VCC down the bottom, and our VDD is going to be up at the top here. So we'll connect our pin 7 to our VCC and our pin 4 to our VDD. Okay, and we'll make our VDD, it's going to be minus 12 volts, and we'll make our VCC plus 12 volts. Now our resistor R1 is going to go at the inverting op amp pin 2 here, and our resistor R2 is going to be on the feedback loop, like so, and we're going to have to connect our non-inverting pin to ground, and we'll take a copy of the Control C, Control V of the ground terminal here. So the ground terminal here is going to connect to the negative terminal on the oscilloscope in channel 1 and on channel 2. Well, we'll take our output and we'll put it on to our B channel, that's our output there, and we'll take our input and we'll put that on to the A channel, so that's our input there. Now we'll take another copy of the ground for the input, so this connection here and the common both go to ground, and our input goes to the positive side of the function generator. So that's it built up. Now we'll go and stick an input in, so we'll put in a 100 Hz and we'll make it a 1 volt peak. So that's a 1 volt peak AC signal, so it'll be 2 volts peak to peak, and it'll just be a sinusoidal function there. So we've put in a 1 volt, and the way this is set up, it's going to be, our gain is going to be our minus R2 upon R1, so it's going to be a value of minus 2. So we should get out a 2 volt peak signal, and it should be inverted. So let's go ahead and see if we get that. So that looks like it's working okay, but we'll change the division down here to 1 volt per division, and you can see it a wee bit better. So there you can see the input is the small signal here in red, which is a 1 volt peak signal, and output is a 2 volt peak signal, which is inverted. Okay, so you can actually see that a little bit better if we connect on the output terminal there and select properties. We can change the colour to a different colour, so we'll change it to that blue colour, and we'll run that again. And there you go, you can see that the output has been amplified by 2, output's been amplified by 2, and it's also been inverted. Okay, so that's all there is for this video. I'll get you on the next video. Okay, bye bye.